Hi folks, welcome to the Neo4j stream. My name's Will, and in today's session, we're going to do things a little bit differently. So previously, last week, we were looking at GraphQL Architect, which is a new low-code application for building GraphQL APIs with Neo4j. So that was our stream last time, seeing how to use this tool to build GraphQL APIs. And before that, we had this real estate Grandstack application that we've been working on. And what I think we'll do with this session, and this is a good time to do it since we already took last week off from our building our real estate app to look at GraphQL Architect, is I want to take a look at how we build the grandstack.io documentation site. So this is the landing page, but it also has all of the documentation for Grandstack and the Neo4j GraphQL JS project. And what I thought would be fun to do today is look at how we build this site, some of the tools like the static site generator, Docusaurus, MDX markup that we use, how we deploy it to Netlify, how we use Graphql to give some live queries inside the documentation. And I'd like to work through some of the GitHub issues that we've been building up and add some improvements to the documentation site. So let's just jump in. So the code for the grandstack.io website is here on GitHub. I'll drop a link in the chat. And so the goal of the grandstack.io site is really to provide a sort of a landing page and portal to Grandstack content, so to link to what's new in the blog, but mainly it is to host the documentation. And if we look at, let's say, the documentation for Neo4j GraphiQL JS, from the quick start, we have some content here. There's also this feedback widget. So on every page we ask, was the content on this page helpful? Yes or no? And if the answer is no, well then hopefully we ask for a little bit more information on how we can improve the documentation. And based on some of that feedback and some of the parts that we know that are missing, we've collected quite a few issues now on the grandstack.io GitHub issues section for improvements that we know we can make to the documentation. So what I'd like to do today is just see how we build the site, how the static site generator works, and then try to work through some of these issues and add some improvements to the documentation. So first of all of this content is hosted on GitHub. So all of these pages are MDX files. We'll talk about what MDX is in a second here. But on the site, each page has an edit this page link, which links in to GitHub. And this repository is public, so anyone can submit pull requests, and it's pretty easy to do that if you have a small change using the GitHub web editor here. So this will create a new pull request with any changes that you want to submit in the editor, or you can pull the repo down locally, build it and run it locally, and submit a pull request that way. Let's take a look at the code. So in the website directory, if we take a look at package.json, we can see some dependencies that we're using here. this Docusaurus dependency. This is kind of the main one. And then we have Prettier and Husky for code formatting. So Docusaurus is the static site generator that we use, docusaurus.io. And specifically, we use Docusaurus 2, which I think is, yeah, still in alpha. So I think we're using alpha, we can see what version, alpha 54, and the current version is 58. So I'll drop this link in the chat too. And so what's really nice about Docusaurus is it's a static site generator using React, but specific for documentation sites. And what's really nice is that we have the ability to add, if we want, sort of our own React components, if we have some fancy functionality or something we want to embed, but it gives us this great static site generator that we can create documentation sites for. It's integrated with Algolia for code search. So if you notice on grandstack.io, if I start searching for things, I have search powered by Algolia. I think Doc Search is what the project is called that powers that. And we use MDX to create the actual content for that. MDX is, I think there's a site, is it just mdx.js? mdxjs.com. There we go. So MDX is a combination of Markdown and JSX, which means we can embed both Markdown, React components, JavaScript, HTML in the individual pages that has the content for our documentation. Then when we build the site, it gets static site generated, and then we deploy it with Netlify. So the GitHub repo, this grandstack.io site, this is connected to Netlify, and that handles builds and deploys for us. So if we jump into Netlify and take a look at grandstack.io project. So I triggered a build maybe like an hour ago where I added these pages here. So how to install and use GraphQL Architect. And when I pushed that up to GitHub, it triggered a deploy for building the site and then deploying it to grandstack.io. So it's pretty nice to maintain that way, that we don't have to deploy anything manually, just get it into GitHub, and Netlify takes care of building and deploying. Okay, so let me say a little bit more about MDX. So let's look at an example of one of the documentation pages. So if we go into docs, we have a bunch of .mdx files. And these pages have the actual content for our documentation. So if we pick one, let's just look at the slow code GraphQL with GraphQL Architect page that I updated most recently. Architect install. And let's look at the raw. So I'll switch over to a code editor in a minute. We won't have to look at unhighlighted code here. But basically, every MDX file, we have some front matter. So each page has an ID, a title, and then a sidebar label. Why all these things seem kind of similar? Why do we need to have these three separate pieces of content? Well, the ID allows us to refer to this page in other MDX pages or reference it in our configuration using this ID, so we don't have to use this long title. And then the title is what's going to show up at the top of the page. So this. And then we have a sidebar label, which is the label that'll show up in the sidebar over here. Okay, so that's the front matter. Then, because this is MDX, so combination of Markdown and JSX, we can import, in this case, some components and functions. So we import this feedback widget. This is a React component that I created that is powering this form. So is this content helpful? Yes or no? That's a simple React component. And then there's a helper function use base URL, which gets us the URL for loading our static content. And then the rest of this is fairly standard Markdown. This page is pretty simple. We'll get some more complex ones. And then at the end of the page, we add our feedback widget components. Cool. So that's MDX at a high level. Let's switch over to VS Code and take a look at our grandstack.io site. So we talked through the dependencies. I don't think there's anything else interesting to mention here. Oh, perhaps, so we do use Graphql. Oh yeah, so that's one thing. That might be a good place to start. So some of our pages, let's take a look here. I think specifically the filtering page embeds Graphql. So Graphql is this tool in the browser that allows us to query GraphQL APIs. And we can also look at the documentation so we can see what data is available, what are the entry points, and so on. And this is really nice to be able to embed something interactive in a documentation site because we can show example queries. But then, of course, as you're looking at the documentation, you can interact with this. You can make edits. So maybe I want this to filter to be, I don't know, greater release date greater than the year, I don't know, greater than 1950 but less than 1920, right? Maybe I want to see what other filter arguments are available. So that's very helpful for me anyway, as a developer, when I'm looking at documentation, if I have some sort of interactive component that I can work through. So we embed Graphql. Right now, I think we just do it on this page, maybe a couple others, and I think there's even some examples that are missing it here. So anyway, in package.json, that's why we pull in Graphql and GraphQL here. And GraphQL, by the way, is part of the GraphQL Foundation's body of work. So here's Here's the link to the Graphql project, where you can pull this into your own project. There's lots of interesting pieces in Graphql. So it's not just this React component that you'll find in the Graphql repo. There's also GraphQL language service packages that you can use for parsing. There's also that also powers autocomplete. So there's a new version of Graphql, the 2.0 beta, and that's in the process of switching over to Monaco. So Monaco is an editor that comes out of the VS Code project. And this Monaco GraphQL includes some GraphQL language service features. This is actually what we use in GraphQL Architect. You'll notice we have some smart autocomplete that's powered by the GraphQL language service project in GraphQL Architect. Okay, cool. So this is what's really nice about MDX, is that it allows us to embed these React components and add some interactivity to our documentation site, but still have the ability to just write Markdown for creating our content alongside that, which is quite a smooth process. So maybe let's start there. Let's start with adding graphical examples to a few more pages here. So first, let's open up this GraphQL filtering page. So website, docs, GraphQL filtering. Let's make this a bit bigger. Okay. So let's see how this works. So we pull in a graphical snippet component from components/graphical snippet. And then when we actually want to use that, looks like we have a div, we add class names. So this is how we add CSS in this case. So styles.graphical container. If we look at our custom CSS that we have for this, styles module CSS. For the class graphical container, we just give it a fixed height and some padding. Okay, so that's adding some CSS. Then inside that div is our graphical snippet component. And then for props, it just takes a query. And that is the query that is pre-populated when the page loads. Well, let's take a look at this graphical snippet component. Here we go. Okay, so this is a component. It looks like this is a functional React component. So for props, yep, it's just taking a GraphQL query. And then it's just rendering graphical. Graphical takes a fetcher, which in this case we're just using fetch. So we're making a post request to movies.grandstack.io, sending the GraphQL query. So movies.grandstack.io is actually the GraphQL endpoint that these embedded graphical components are hitting. So let's take a look at that. So movies.grandstack.io, this is this a bit bigger. This is a sample, sort of a demo GraphQL endpoint that has data about movies and users who have rated those movies. This is the same data set that's used in the recommendations Neo4j sandbox. So if you've ever used that, let's take a look at that. So Neo4j Sandbox allows us to spin up Neo4j datasets that are hosted for us in the cloud and run queries against them. So this is the same dataset that's being exposed through that GraphQL API at movies.grandstack.io. In this case, though, this GraphQL server, so this is actually a serverless GraphQL API that is running on Vercel. If you're familiar with Vercel, it used to be called Zeit. I don't want the dashboard. We were using, I think we used Vercel a few weeks ago as one of our deployment options when we were deploying our Grandstack project initially. Anyway, Vercel allows us to deploy serverless applications, and in this case, that is where our movies.grandstack.io GraphQL API lives. Okay, so Neo4j browser for our recommendations data set. I just want to take a look at this data in Neo4j so we can get an idea of what that looks like. And also, if you're interested in learning more about recommendation queries in Cypher and Neo4j, this is a great resource. The recommendations sandbox walks through using some graph algorithms for this, for generating recommendations based on movie ratings, which can then be applied really to lots of different domains. So let's do DB Schema Visualization. All right, so we have actors that acted in a movie, users that have rated the movie, directors, and movies are in a genre. I think in most cases, let's just look at some movies. There's Money Train, and we can see the genres that it's in, who's acted in it, Jennifer Lopez, who's rated it, and in the case of the rating, we're storing the timestamp for the rating and the actual rating, so the number of stars, as a property on the relationship. So we'll see how to work with that in GraphQL. And 1 star for Money Train. This guy gave it a 4. Okay, anyway, so that's the data that we're working with. So this is our GraphQL API that we're hitting from Graphical embedded in our documentation. And this is nice. We can use this for building sample applications or demos, since GraphQL Playground, which is this tool that we're using, is just hosted on the domain itself. Okay, cool. So let's see how we can add Graphical to some other query examples here. So let's fire this site up locally. So I'm going to go into website directory and npm run start. And it's going to start up the development web server. So now we're loading this off localhost, and if we go to docs, filtering, here's the page we want to work with. So it looks like we have graphical examples for most of these examples of filtering, but we don't have an example for spatial filtering. So with spatial filtering, this allows us to pass in a point and a distance, and we're going to search for nodes that are within that radius distance of whatever point we pass in. So that's super useful for finding things closer to other things. So let's see, how can we add this? Well, I don't think there's anything in our movies schema that is going to allow us to use the spatial filtering. We just have movie genre, actor, user. We don't have anything with a point location on it. However, there is another, keep my tabs organized here. There is another GraphQL API that we could use, businessreviews.grandstack.io, I think. There we go. So this is a slightly different GraphQL API that we can use for demos as well. Let's zoom in a bit. This API is using the sample data set from the Grandstack book, which is just some sample businesses and users that have written reviews of businesses. But the important point here is that all of these businesses have a location with a latitude and longitude. And I think this is the data set that we used for our filter example here. So I wonder if we can actually just copy this query. And if we run this, yeah, cool. So what I want to do now is, instead of having just this static results, what I want to do is replace this with this graphical component that allows us to query it interactively. Well, we want to reuse this graphical snippet component. However, this graphical snippet component, it has the endpoint hard-coded right here. So let's pull that out. So now we'll make each usage of the snippet pass as props the endpoint that it's going to use. So then that means in Graphql Filtering, for all of these examples, we need to pass along the endpoint as well. So add that. It's a little bit of repeating ourselves here, but I think that's okay. Since we could end up with lots of different endpoints that we want to hit. I suppose we could define these as globals somewhere and reference those, or maybe an enum or something, but I think that's fine. Okay, so let's switch to the localhost version and let's see if that works. Yep, cool. So we're still able to send queries to movies.grandstack.io. And now let's add our spatial filtering example. So instead of movies.grandstack.io, it's going to be businessreviews.grandstack.io. But we'll use the same query that we have here. Okay. So now if we take a look at that, we have our business query and with our filter example, and yep, there's our results. Cool. So the formatted version of that, I know Prettier likes it to all be on one line there, but we have it broken up so it's a bit more readable. I think that's fine like that. Okay, cool. So now we can take out the GraphQL query and GraphQL result. Don't need that anymore. Okay, cool. So that's spatial filtering. What's the next example? Filtering criteria. Oh, I see. That's just all of the possible examples of filters that we can use. So, okay, I guess we don't have any more graphical examples. These all are covered. So let's just go ahead and push this page up to GitHub and let's watch it do a deploy. So now we need to push up two files. So if we look at the changes we made, we added the endpoint prop to our graphical snippet component, and then we added the movies.grandstack.io to all of the, passing that as a prop in all of the existing graphical snippet usages, and then we added our new example using our business API. Cool. Oh, and I also ran Prettier, which changed a few things as well. That's okay. Okay, so components, graphical snippet, git add docs, GraphQL filtering, commit. We'll say that we added business GraphQL API example. And git push. Okay, so that pushed up to GitHub. So now, if we go to Netlify, which I have open in one of these tabs, and if I take a look at the deploys, I can see that Netlify picked up the commit and is now building the site, and then we'll deploy that when it's done building. Cool. So while that's building, let's take a look. Are there some other places that we could include graphical? So our quick start, this is just kind of showing how to get things up and running. User guide goes into a bit more detail how that works. Schema generation and augmentation. This is showing how the schema is generated and the different arguments that are added. We don't have any example queries in there. Filtering with GraphQL, that's now covered. Relationship types. So defining relationships in SDL, relationships with properties. Relationship mutations, see the generated mutations section. Okay, this page is a little sparse. I think this could do with some attention. So this might be a good page to work on next. We can add a graphical example, I think both showing how to, once you've defined a relationship field, how to then query, both in the case of if that relationship does not have properties and if it does have properties, because that's a little tricky. If a relationship has properties, then it gets promoted to its own type in GraphQL. Here we have our rated example. So that might be a good case to add a graphical example. Okay, let's check in on our Netlify build. And it says it has built and deployed to the edge. And we can now go take a look. And if we go to docs, GraphQL.js, filtering. So let's make sure that our movies graphical examples didn't break. These look good. And check on our spatial filtering example. Cool, that looks good. And we can tweak things a bit and yep, we get different results. Cool. Okay, let's now go to, which page is that? The relationship, GraphQL relationship types. Let's do a little split screen, split right. So the first thing we'll do here, let's go ahead and run our server again. You can see our changes. And the relationship types page. This one. Okay, cool. So the first thing I think we can do is let's add some graphical examples, both in the case of where we're going or following relationship field from movie to genre, in the case of a simple relationship field where we have no properties on the relationship, and then the more complex example where we have this rated relationship with properties that gets promoted to a type. Cool, so we've got our feedback widget. So I think the first thing we'll do is import graphical snippet from components, graphical snippet, and styles our CSS file. And let's toggle word wrap so we can see everything. There it is. Okay, so GraphQL types can reference other types. When defining your schema, use the relation GraphQL schema directive on the fields that reference other types, for example. Type genre. I'm not sure why this says attribute. This should be genre, not attribute. And, oh, hi, Isaac. Isaac says, thanks for all your videos and streams. Yeah, thanks for joining, Isaac. Let me know if you have any feedback or questions. So what's the example query that we want to use here? Well, for genres, it's pretty limited, I guess, in what we can show. Maybe something like this, where we just look at the first movie and just traverse to the genres. That seems to make sense. But maybe let's add some explanation here. So defining relationships in SDL like that, and then maybe querying relationship fields as a subheader, and then something like relationship fields can be queried as object fields in GraphQL. For example, and then here we want to include let's add a bit more here. Relationship fields can be queried as object fields in GraphQL by including the fields in the selection set. I guess that's accurate. Okay, for example, here we query genres connected to a movie node. And here we're going to add our graphical example. So we want a div and add the graphical container class to it. So we just get our fixed height and the padding, whatever styles we added in there. And then in here is going to be our graphical snippet component. We need to pass the endpoint as props. This is going to be business reviews.grandstack.io. And the query is looking at one movie and then traversing to its genres. Okay, so we'll save that and take a look. And so here's what I love about Graphql is I have this little syntax highlight error that says cannot query field movie on type query. Did you mean review? So why am I getting that? Well, I passed in the wrong endpoint. So this is my business reviews. I want movies. So let's change that to movies. And movie, first one, title, genres, name. Cool, there we go. Constantine says, is it possible to sort query results by nested field? So, do you mean something like this? So where we want to order our genres by name. Looks like they're already in ascending order, so maybe in descending order. Something like that. Yeah, so I say, for example, sort movies by genres title. Oh, I see. You mean sort query results by a nested field. So we can do like this example. Let's make sure this is big enough. We can do this example, right? So we can order within nesting in our selection set. But in this case, we're ordering just this piece of the selection, right? This ordering doesn't apply to movies. So for example, if, I don't know, if we pulled in 10 movies, the ordering options that we have for movie at this level are the properties on movie. So we can order at the movie level of the selection set by any of the properties. So we can, I don't know, order by title in descending order. And then, oh, and note, these are some characters that have some accents and non-alphanumeric characters here, which is why we're seeing some of those first. Yeah, but anyway, to answer what I think is your question is, I think you're asking if we can then order movies by some aspect of genres. So I don't know, maybe, I'm not sure what that would look like. We can do nested filtering, but we can't do that sort of nested ordering. I mean, what you could do is add a cipher directive field to movie that could then traverse to genres and check if it's connected to some certain genre and then order by that. But we can do filtering. So for example, maybe we want to filter for genre, so movies, I'll explain this in a second. Movies, genre, sum, where the name of the genre is, let's say, crime. So genres sum is now going to filter at the movie level, where movies are connected to at least one genre node with the name crime. And then it applies that filter at the movie level. And then we're grabbing all of the genres for each of the movies that have the genre crime. We could also apply filter at this level, where name is crime. And that's going to filter now at the genres level. So it's independent of our filter at the movie level. So if but we're only seeing the crime genre, even though these movies have other genres, we can remove this filter now from here. Oops, don't need that curly brace. Right, and now notice we're seeing no genres at all, or we're seeing the crime genre. So even though we have this filter for the genre with the name crime here, that filter is being applied at the genre selection. So we're still seeing movies that don't even have the crime genre connection, but then we're not seeing any of their genres because the filtering is applied at this level. Anyway, so I hope that answered your question. The answer, I guess, is not really, at least for what I think you were wanting to do. But yeah, I think look at the cipher directive, maybe those add like a Boolean or something, and then, or maybe it's the number of genres that we want to order by. That might be a better example. And that we can do. We'd have to add a GraphQL a cipher schema directive to add a computed scalar field. So maybe we want to, let's say, order by the number of genres that movies are connected to. We'd add a cipher directive field with a statement kind of like this, but it would say this in genre return count of the genre, and then we then have like a genre count field on our movie node that we could then order by. So that might be more in line with what you want. Okay, cool. So it looks like this example is working. Querying relationship fields. But then we have an example of relationships with properties. So the above example, annotating field with relation, works for simple relationships without properties, right? So let's make sure we understand exactly what that means. So movie in genre genre return star limit 10. So here we're just going to look for 10 paths connecting movies and genres. So here's, zoom in a bit. Here's the adventure genre. It's connected to a bunch of movies like Hercules, what is this? Transformers? Transformers Age of Extinction. Okay, so these are adventure movies, and if we look at the in-genre relationship, there's no properties. All the properties are on the nodes. So genre has a name. Movies have like title, rating, votes, language, but genre has no properties. So if that's the case, then we just have a simple way to represent those as just a single field in GraphQL. But in the case where we have ratings, so in this example, so here's Christina rated Money Train, and now we have some properties on this relationship. So we can't model those in GraphQL as just a field. We need to promote that relationship to its own type. And if we do that, then we have something like this, where a user rated, and the connection from user to rated now is this object, where we have a from and a to field, and we have the properties on the relationship as fields on the type, so rating and timestamp. Cool, so let's add a graphical example that shows that. Actually, first, let's do it in GraphQL Playground. So how would we query that? Maybe let's just search for a user, just one user, and let's look at all of his ratings. Rating and created, which is a date time. Okay, so here's just our first user. He has a bunch of ratings, and we're grabbing the properties of those. Now, each of these ratings is connected to the user, which we're seeing, but it's also connected to the movie. And in that case, we have a movie field that we can add to the selection set. So let's grab the title of the movie. Okay, so now we can see the movies that this user rated and the ratings that he gave them and the time, the date and time that he created those. Okay, cool. So this looks like a good example to include. So we're showing how to query relationships with properties. So relationships with properties, rated. Let's change this in the SDL, the schema definition language, to match. This is a date time. So that's what we actually have in our API. Okay, this approach of an optional relationship type allows for keeping the schema simple, and we don't need relationship properties to have the flexibility of handling relationship properties when we want to model them. Sure. Relationship queries. Queries are generated. Blah, blah, blah. So this would be created date time. Well, because this is the example after it's gone through augmentation, so it's actually in the Neo4j date time. Okay, let's change this to match the example we had up here a bit. Querying relationship fields, relationships with properties. So this is going to be querying relationship types. For example, and let's say here we query for a user and their movie ratings. Yeah, let's add something more to that in a second, but let's add our graphical snippet. So first div, get our styles, then our graphical snippet component, and this is going to be the movies endpoint. And our query is this. Okay, let's see if that worked. Querying relationship types. Here we query for a user and their movie ratings. Cool, that works. Let's add a bit more here. So here we query for a user and their movie ratings, selecting the rating and created fields from the relationship type, rating, and created fields from the relationship type, as well as the Ruby node connected to the relationship. Okay. Cool, that's a good example. Okay, and then this relationship mutations section where we just link to the generated mutations section. That could use a bit more, I think. So what I want to make sure is that we cover adding and removing relationship types, not just relationships without properties. So if we have relationships without properties, then we use a mutation like this. Yeah, so we don't have examples here. We just sort of show the generated mutations. So I'd like to add examples here. But then if we have the case where we have a relationship type, so a relationship with properties, then we use these input types. In this case, a rated input is generated, which has all of the fields on the relationship, and that goes under data. So in the data argument, in this case for the add movie ratings mutation. Okay, so we cover what the generated mutations look like. I think we could use some better examples though. I guess the trouble here is we can't actually run any mutations in our graphical example, since we just have a read-only user connected to the database. We want to make sure that someone isn't able to delete all of our sample data, for example. So we'll have to figure out a better way to handle mutation examples. But let's think about that later. Okay, so we've added this example these couple of examples to the GraphQL relationship types page. We'll have to come back to relationship mutations. Let's push this up for now. We'll stop our server, git add docs GraphQL relationship types, git commit -m, add graphical examples for querying relationships. And we'll push that up and let Netlify take care of the build. Okay, so what else do we have here? So that's relationship types, temporal types, date time, temporal query arguments. Yeah, so we could add some graphical snippets here. Let's take a look at the issues though. Let's see. Is there something more we can add besides just graphical snippets? I could probably do that all day. There's plenty of examples for that. Let's see. Document using multiple databases with infer schema. Using documentation for multiple databases with infer schema. Oh yes, this is an example of something that comes in on that feedback form in the documentation. So as you're reading this and you see something's missing, definitely please fill these out. Actually, let's add one. Make sure we don't miss our relationship types. So it has missing information. Please add examples for relationship mutations for both simple relationship fields and relationship types. So relationship fields are when we have no properties on the relationship. Relationship types are when they have properties. So make sure we don't cover that. We don't miss that. Isaac says, if a user has rating tendencies, always rates pretty low or really high, can then calculate a particular rating's relative position within their tendency and then translate what that means. Yeah, that's a really good observation. So when users are rating something, everyone has kind of like a different basis, right? So you may go to a movie and I think it's great and fantastic, but maybe I never rate anything a 5. So like the highest rating I'm ever going to give is a 4, whereas that's equivalent to someone else's 5 because they're more likely to rate things higher. Isaac says, is that something that would have to be done outside the software, or does this have enough calculation power to figure out that type of thing? Yeah, so there's different types of similarity metrics, I think, is where this would come into play. There's an example of this in the recommendation sandbox. So let's close these. So there are these similarity metrics that are used in collaborative filtering. So let's say that we want to generate recommendations. One way that we can do that is to find users who have rated things similarly. And to do that, we then use a similarity metric to calculate that. So like, who are the users that have rating tendencies most similar to mine? What movies have they watched that I haven't watched? Those are probably good movies to recommend me, right? That's the basic idea of collaborative filtering. And when we start looking at these similarity metrics, we have a few different options. Let's see here. So one example is cosine similarity, where we're basically calculating cosine distance between the weights of a user's rating. So it basically generates a vector. So like, what are all of the movies that I have rated? What are the numbers for those ratings? Pull that into a vector. For some other user, Bob, what movies did we both rate? That's going to be another vector of numbers. And then cosine similarity is just calculating cosine distance between those two vectors. Sounds like a lot. We can do that in bare Cypher here. So here's sort of how to do that in Cypher. There's also built-in procedures for doing that. The problem, though, with cosine distance is, as Isaac pointed out, is like users have different baselines for their ratings, right? Like I might consider something a 3.5, and I think that's really good because I have tendency to never give out a 5, but someone else might rate that a 5 as that's really good. So in that case, there's an algorithm called Pearson Similarity, and the nice thing about Pearson Similarity, Pearson Similarity, is that it calculates the mean rating for each user. And so Pearson Similarity is a correlation about the mean rating. So it takes into account, and here we can see this computed just in Cypher, takes into account, as Isaac said, the tendency of a user, right? So what's like the average rating that you give, and is a rating for this movie, is that above or below? And that's factored into that algorithm. So we can do that in Cypher, or here's an example where we're using the Graph Data Science library to just do this in a single function call. If we search for Neo4j Graph Data Science Pearson Similarity, we can find some examples, and there's a few blog posts that talk about this as well. Yeah, so we can do this in just, here's an example using the Graph Data Science library. So anyway, so that's how we can do that in Cypher using Graph Data Science library. How would we then sort of pull that in to our GraphQL API? Well, again, that's going to be sort of through the use of a Cypher schema directive. So in this case, maybe we would use that by adding a recommended field. So here's an example where we have a business type, and we add a recommended field that is an array of businesses. So if you like this business, what are other businesses you might like? And here we could do a Pearson similarity to find examples, taking into account that sort of mean tendency of the user. Cool. So that's a little rambling answer, but hopefully that's kind of what you're looking for. Constantine says, hello, everyone. Hi, Constantine. Welcome. Okay. Hi, Lubo. Cool. So we were looking at, the issues. That's what we were doing. Looking at the issues. Right. So our first issue is document using multiple databases within first schema. What else? Isaac says that gives me something to read and work through. Yeah, definitely check out that recommendation sandbox if you haven't used that, because that has a few different approaches. There's also Neo4j.com/Graph Academy. Did I spell it right? Yes. So there's some online trainings. Courses, online training. So there's an online training that I'm looking for, which is this one, Applied Graph Algorithms. So this course uses the Graph Data Science library and some data from Yelp. So Yelp releases every year a public data set of a sample of businesses and user reviews. And this training goes through the process of building a React application that uses graph algorithms to improve things like search and recommendations, and it does some image machine learning tagging using the Google Vision API to then see how you can use tags on images to improve recommendations, and goes through some different algorithms. So anyway, so that one might be kind of relevant as well. So I'll drop the link in here. I would check that one out. But anyway, there's lots of content out there. There's also the Graph Data Science book. Graph Data Science library. Yeah, this one, which I think is available to download for free until the end of the month. Yeah, so this is an O'Reilly book that has lots of information about these kinds of graph algorithms. So yeah, tons of resources out there. Definitely an interesting area. You can sort of go as deep as you want to there. Okay, cool. Well, I think we might call it good there. We made a little bit of progress. Let's take a look at our site. Let's make sure Netlify finished that last deploy. So the last thing we updated was the relationship types. Yeah, and we added a couple of graphical embeds here for showing some examples of querying relationship types. Cool. So, oh, Isaac already has the book. Great. Cool. I hope you're crawling through it. Yeah, cool. Yeah, so I hope that book is helpful for you. Definitely let Mark and Amy know if you have any feedback. You can ping them on Twitter. I'm sure they'd love to hear any feedback on it. Cool. So that I think is it for today. Thanks for watching. As you're looking through the documentation, again, it's super helpful to send any feedback that you have, or if you want to send a pull request, all of the pages have that edit button, or you can submit a pull request through GitHub to the documentation. So we've got a lot of issues here waiting for some documentation improvements. So we'll slowly work through those. But anyway, thanks for joining. Next week, I don't know, we'll probably pick up our real estate search app again, since we've been off that one now for a couple of weeks. Or I don't know, we might do something else interesting. So we'll see how it goes. But anyway, thanks for joining, everyone. Have a good night.